Today we're going to look at proportions. So we're just going to start out really simple. Given the fraction a half. All right, so we've got a half down here. What are three equivalent fractions? Okay, so if I have a half, okay, so remember equivalent, it has to, whatever I do to the top, I do to the bottom. So if I multiply the top and the bottom by 2, I get 2 over 4. So an equivalent fraction here would be 2 over 4. Notice if I reduce that, I still get a half. If I multiply the top and the bottom by 3, I get 3 over 6. So notice that 3 over 6, I could still divide both of them by 3, and I get a half. I could also do a half multiplied by, I don't know, let's go 6. So I get 6 over 12. Notice that if I divide both by 6, I still get a half. And there's, of course, lots of them. So these fractions, 2 over 4, 3 over 6, 6 over 12, 1 over 2, are also known as equivalent fractions. Something you've seen before. And they occur when the rates are equal. Okay, we can call these rates as well. We also can say that the equivalent rates or ratios are proportionate. Okay, so this is the new vocabulary for today, proportionate. If an equation is proportionate, then the fractions must be equal. Okay, so what do I mean by that? Well, if I had 1/2, this could equal, an equation has the equal sign, 3 over 6. Notice that I could reduce the top and the bottom by 3 here, and I still get a half. So a half equals a half. Check. So we're going to look at a few different types of questions that involve proportion today. So we want to be able to answer, are the fractions proportionate? So that's kind of like what we did with the example. And we also want to find the missing number if a fraction is proportionate, given equations and word problems. Alright, so let's do the first one. Are fractions proportionate? So example 1 says, determine if the following fractions are equivalent. Okay, well, first thing that we might want to do is we have a comparison of fractions. We have 3 over 5 is equal to 5 over 8. Our best strategy is to multiply both sides by the common denominator. So in my denominator, I have 5 and 8. Okay, so I've got 5 and 8. So the lowest common denominator for 5 and 8 would be 40. Alright, so I'm going to multiply both sides by 40. So right now I have 3 over 5 is equal to 5 over 8. When I multiply both sides by 40, I'm going to find that the denominator is going to go away. Because remember, I can just write this as 40 over 1. And 5 goes into 40 8 times, and 8 goes into 40 5 times. So on the left-hand side of my equation, I end up with 8 times 3, which is 24. And on the right-hand side, I get 5 times 5, which is 25. But 25 doesn't equal 24. And therefore, we say that these are not equivalent fractions. I'll just put the fractions in brackets here. Okay? If they were equivalent, then the left-hand side would have to equal the right-hand side. Because the left-hand side does not equal the right-hand side, they cannot be fractions. I'll put that in brackets. Alright. The second type of problem you might have is I want to actually know what the equivalent fraction would be. Alright, so same idea, okay? First things first, multiply both sides by the common denominator. Okay, so our denominators are 15 and 5. So the lowest common denominator between 15 and 5 is actually 15. So right now I have x over 15 is equal to 2 over 5. Well, if I multiply both sides by 15, remember this is like 15 over 1, and I can cross-reduce. So 15 divided by 15 is 1, and 5 divided by 15 becomes 3. So on the left-hand side, I have 1 multiplied by x, which is x. The bottom is just 1 times 1, which is just equal to 1, so we don't have to put it there. On the right-hand side, I have 2 multiplied by 3, which is 6, over 1 multiplied by 1, which is just 1. So my answer is x equals 6. Okay, so this is my answer. I can always check this. So if I substitute x back in, so before we had x over 15 is equal to 2 over 5, well, if I substitute in the x, I've got 6 over 15 is equal to 2 over 5. Now, notice that the right-hand side is already in its most reduced form. If it's not, you can reduce it. It's the left-hand side which is not in its most reduced form. Notice that 6 and 15 are both divisible by 3. So if I reduce this, divide by 3 I get 2, divide by 3 I get 5. What I really have on this side is 2 over 5. And notice that 2 over 5 does in fact equal 2 over 5. And therefore I solved for it correctly. Alright, well what about a word problem? Okay, so if Miss Carlbeck drove 140 kilometers on 9 liters of gas, how many liters would it take to drive 200 kilometers? Okay, so it might seem a little daunting at first, but notice that we're going 140 kilometers on 9 liters. Well, you saw this with rates. So really all I'm saying is I'm going 140 kilometers on 9 liters of gas. And I want to know how many liters it's going to take, so how many liters it's going to take to go 200 kilometers. Notice that what I've done is I've set up the kilometers are both on top and the liters are both on the bottom. Alright, we don't actually need the units to solve for this. They do actually cross-reduce, but to make our life easy, we can rewrite this like this if we want. And for the number of liters, I don't know, let's call it y. Alright, because I don't know what this one is. So I'm going to multiply both sides. Now you can do the common denominator if you want. So the lowest common denominator between 9 and y, well, that's just actually 9y. So you can multiply both sides by 9y, or you can remember from last unit when we were doing algebraic equations, if I multiply both sides by y, because my goal is to get y equals, and right now the y is on the bottom. So if I multiply both sides by y, remember this is like y over 1, then on the left-hand side I have 140 y over 9 is equal to 200, and y divided by y, remember that y is just a number. So any number divided by itself is 1. So I'm left with 200. Now, again, my goal is to get y equals to something. Right now, it is not y equals because of this 140 divided by 9. Now, you can do this a few different ways. You can divide by 140 over 9, and you do that to both sides, which a lot of you do. The other thing you could do, which is the same thing, is multiply by 9 over 140. Okay, and this is in fact the exact same thing. So there's two different ways you can do it. I'm going to go run through it this way over here, then the blue, and then if you want to run through it your way, as long as we get the same answer, it's perfectly fine. So on this side, 140 divided by 140 is 1, and 9 divided by 9 is 1. So on the left-hand side, I'm left with y. On the right-hand side, I can put 200 over 1. Now, right away I see that we've got some zeros here, so I can reduce both by 10, so I have 20 and 14 here. And then, again, they're both 20 and 14 are divisible by 2, so I'm going to reduce this to 10 and divide this by 2, I get 7. So what do I have? Just so I can see, I've got 10 over 1 multiplied by 9 over 7, which is just equal to 90 over 7. There's nothing I can reduce there anymore. And if I want to know in in this case I do actually want to put it into decimals because I want to know how many liters it actually took me to drive. And it's pretty hard to see how many liters that is 90 over 7. So I'm just going to do long division, and it's 90 divided by 7. 7 goes into 90 or 9 one time, and I'm left with 2, and I pull down the 0, and that can go in twice, and I get 14 and 6. Put my decimal in, pull down a 0. That goes in 8 times, and it's 56. I have a 4 as a remainder. I'm going to do it one more time. 35, which is 5 times, and it'll keep going on, but 2 decimal places is nice, so I get y is equal to 12.85, and it's liters, right? If you forget, go back up to the question. What am I looking for? How many liters? And notice that even here, I said y liters, okay? So my y is 12.85 liters. And whenever we have a word problem, we want to finish it with a sentence. So I would say it would take 12.85 liters to drive 200 kilometers. And that would be my answer. Now, just for setting things up, all that I did, okay, really important here, just if we're a little bit confused, we have 140 on 8 liters. Okay, so I went 140 kilometers per 9 liters. And we know that we could set it up like this from our rate section. And then I want to know how many liters it would take to drive 200 kilometers. So because I've put kilometers on top here, I must also put kilometers on top here. Because I put liters on the bottom here, I can put liters on the bottom here. And that's really all the only reason I set it up that way. You could have set it up the other way where you had 9 liters over 140 kilometers, and that would have been perfectly fine as well. If you did that, we would get 9 liters per 140 kilometers. And I would have wanted to go, I'm not sure how many liters it's going to take me to go 200 kilometers. You can still solve this doing kind of the same method, and you'll still get the same answer. You'll still get 12.85 liters. You would just solve it a slightly differently.